Hi guys, now we're going to talk about the Bernoulli's principle. This principle is related with a lot of important things, such as the phenomenon that makes the planes flat. It's a difference between the pressure in, like an example on the plane. There's a force, like with the wing, that there's some air that goes below that has a different pressure due to the velocity. Uh, well, as I said, there's a difference of the pressure. And the formula basically says that there are two different pressures. In the case of the hair dryer that you will see later, there's the one pressure related with the hair dryer at with the exterior air. Actually, it's kind of something related with the energy formulas, like the kinetic energy or the potential energy. Well, the pressure one equals to the half of the pressure multiplied by the velocity squared, obviously. In this case, it is due to the velocity of the hair dryer plus the pressure and the gravity and the height. These help us to the all the particles of the surface were in it. In addition to it, well, the other side that was like in the case of the hair dryer and the ball. The other one is basically the same, but are the phenomenon on the outside, like for example in the atmosphere. I don't know, and that can help us to preserve the ball when it's not static. The ball will stay there, and when it is vertically, there's other things related like the normal force, kind of, which is related with the formula force equal to pressure multiplied by the area. That's in case of the surface we are studying. So basically, that's how the Bernoulli's principle works. It is something that helps us a lot, and we use really often. Like every time we look up and we see a plane, that phenomenon is happening every time. Okay, well, basically that's the theory. Now I'm going to show you which is the procediment to make this phenomenon happen. First of all, we need it's really simple. We need a hair dryer, any kind of dryer, basically a one which have enough capacity of throw a big amount of air, and a ball. It has to be really light because if it's heavy, it could be a problem because the hair dryer wouldn't have enough power. As you see here, this is basically our phenomenon. In this case, the ball fell down because as you see, it is not a symmetric ball. Form it does not help us to stay statically, but it works pretty good to show the explanation. Imagine that here we have our all our normal air, and we have an air that came from the hair dryer that throw a lot of air. There are combination between each one, and if we follow the formulas, there are see there is the pressure number one over here, which is basically our normal air, and the second pressure, which is formed by the hair dryer. As I said, it's important the velocity that produce the hair dryer. Let's put it in yellow. This velocity, and even the height, which each is produced. It's important to have a certain result because the power that the hair dryer dose is kind of limited. So, like, if we contemplate this phenomenon, basically it will work quite good, considering this and the formula aside. So, thank you.